Hey guys, Mr. Richardson here. Let's take a look at our homework 11.3 and hopefully get some pointers on how best to do this. So, stock solution. We can get a stock solution of 1.00 molar NaCl is available. How many milliliters would you need to make 100 milliliters of 0.750 molar dilution? Okay, so we are looking, they tell us right off the bat, how many milliliters of our stock solution. So that's what we're looking for. So that's what we're going to start with, question mark, stock solution. We have three numbers, and only this one has the single unit. So I'm going to start with that, my 100 milliliters. Now let's identify, is this my dilution or my stock? Well, it says up here, my stock solution is 1.00 molar. This one's less, so this must be my dilution. Cool. Hey, again, just some experience speaking here, but I know that with milliliters and moles, they don't really go together. So my first step, I'm going to take 1,000 milliliters of my dilution and convert it into liters of dilution. So there we go. Next up, we know liters is going to go on bottom. Liters of dilution. With liters, we can go to moles. We just have to know, are we looking for our stock or our dilution? And that little DLT right there is going to help us. We're looking for the dilution, which is 0.750 moles per liter. That's what that big M means. So next up, and I know we're working with NaCl, so I'll make sure I do a better job of labeling there. All right, next up, we know we need moles of NaCl on the bottom so that it cancels out. And now we can go to liters of stock. We just have to know what moles per liter it is. Again, that's what big M is. This is 1 mole per liter. There's my 1 mole per liter of stock solution. And then my last step, I don't want liters of stock, I want milliliters of stock. So I'll cancel that back out and go to milliliters of stock. Now it's time to compute. Again, for those of you who like to cross off the units, milliliters dilution is gone, liters of dilution is gone, moles of NaCl is gone, and the liters of stock is gone. So the only thing we have left is milliliters of stock. That's exactly what we want. Let's check and see how we do. 100.0 divided by 1,000 times 0.750 divided by 1 times 1,000. Check for significant digits. We've got 4 there, 3 there, and 3 here. So I need to add 1 more significant digit. We're going to need 75 milliliters of stock solution. So I'd take my 75 milliliters of stock solution, I'd add 25 milliliters of water, and I'd have my 100 milliliter dilution with a concentration of 0.750 molarity. Cool. That was number 1. Let's take a look at number 2. A 0.500 molar solution is diluted to 500 milliliters of a 0.150 molar solution. How many milliliters of the 0.50 molar solution are required? Okay, well, again, stock, dilution. The stock is always the more concentrated version, so that makes the 0.500 molar our stock, and the 0.15 molar our dilution. So we're looking for how much of our stock is required. So how many milliliters of stock? Again, we've got 3 units here. We got 0.5 molar, we've got that twice. We've got 500 milliliters, and we've got 0.150 molar. Again, that big M is a double unit. It's moles per liter. So let's start with the single unit, which is 500 milliliters. Is that my stock or my dilution? Well, it says 500 milliliters of a 0.15. We just a minute ago said this is our dilution. So that means this is our dilution. Cool. Again, just experience speaking. We have molarity. We have milliliters. I want liters. So my first step, I'm going to go from milliliters to liters. Cool. Now that I've got liters, I know I want liters on the bottom. Where can we go with liters? Well, we can go to that awesome little unit that we call the mole. 1 liter, we're working with dilution. So we're looking for a lower concentration. That's this one here, 0.150 moles of dilution. Now they didn't tell us what moles we're working with, so I'm just going to leave it as moles this time. I know moles is going on the bottom. This time I'm going to go to liters of stock. It's 0.5 moles per liter. So 0.500 moles per liter, that's what that big M stands for. Final step, just like it was before, I don't want liters of stock. I would like milliliters of stock, like the question states here. And if you like crossing out your units, then nothing left but milliliters of stock, which is exactly what I want. So let's compute. 500.0 divided by 1,000 times 0.150 divided by 0.500 times 1,000. And I got 150. Let's check our significant digits. I started with 4. This number here has 3, and this number here has 3. So we want 3 significant digits. I'm going to put a decimal point after that 0 to make it significant, and put my unit on there. We're going to want 150 milliliters of stock solution. And if you really want to do the math, then you can figure out how much water you need to add to get it up to 500 milliliters with a concentration of 0.15 molar. All right, fantastic. We are 2 problems deep. Well, let's take a look at number 3. All right, number 3 is asking us a little different problem. What is the concentration, volume to volume, of 175 milliliters of alcohol diluted with water to a total volume of 275 milliliters? All right, well, it always helps to start with what we're looking for. We need milliliters of solute over milliliters of solvent. Sorry, solution. Mess that up way too often. Not solvent, solution. Sorry about that. All right, so what do we have here? Well, there's our solute, 175 milliliters. We get a total volume of 275. That's our solution. And how about that? We've got everything we need. We're done. Let's not forget to multiply by 100%. Three significant digits. I got 63.6%. Now, I'll be honest with you. Technically, there is more alcohol than there is water. We can all kind of do that math in our head. If we have 175 milliliters of alcohol and 275 total milliliters, that means we have 100 milliliters of water. Technically, the solute is whatever there is less of. So technically, we should be saying we're dissolving the water, the 100 milliliters of water, in the 175 milliliters of alcohol. So technically, the waters are solute, and the alcohol is our solvent because there's more of it. But for right now, I'm going to leave this as it is and call it 63.6% alcohol by volume. And now we are on to number 4. I add water to 100 milliliters of a 0.15 molar NaOH solution until the final volume is 150 milliliters, what will the new molarity of this diluted solution be? All right, well, again, they're asking for us something slightly different. What will the molarity, the new molarity, be? So question mark, moles per liter. That's what molarity is, moles per liter. I'm going to go ahead and write my DLT right there because we're looking for a new dilution. All right, so this is equal to, I want liters of dilution on the bottom, I want moles on top. There are a lot of different places we could start here. I'm actually going to take a look at this number here and say, hey, that is a moles. That is my number of moles right there. So I'm going to start with that, 0.15 moles of NaOH per 1 liter. I'm going to call that my stock because that is my stock solution there. So 1 liter of stock has 0.15 moles in it. And there we go. We're done with moles. We've got moles. We wanted moles. We're done on top. We just need to get our liters of stock to liters of dilution. Well, again, I take a look at what I've got. I've got milliliters and I've got milliliters. So first step, I'm going to convert my liters into milliliters. Pretty easy conversion there. All right, now I know I need stock solution on top. 1,000 milliliters of stock. Well, guess what? This is 100 milliliters of stock. It's 100 milliliters of my concentrated volume. I'm looking for my diluted volume. So this is my stock. That means that's my stock. So here we go. 100 milliliters of stock on top. Now I just got to get milliliters of dilution on bottom. My final volume is right there. There we go. Hey, one final step. We want liters of dilution. We currently have milliliters of dilution. And there we go. Check this out. Again, I don't want to cancel out moles. I want moles on top. Put my liters of stock, cancels out. My milliliters of stock cancels out. My milliliters of dilution cancels out. I'm left with liters of dilution on bottom. It's exactly what we want. Well, let's crunch. 0.15 divided by 1,000 times 100 divided by 150 times 1,000. My calculator's telling me 0.1. Let's check our significant digits. I have 2 there, 4 there, and 4 there. I just want 2, but that means I need to add 1 more 0 to get this to be significant. 0.10, there's my 2 significant digits, and that is big M NaOH. So there's my new molarity of sodium hydroxide. Problem number 5, what mass? Okay, so right off the bat, I know I'm looking for a mass. We measure mass in grams. So what mass of magnesium fluoride would be found in 2 liters of 0.440 molar MgF2? This is a single unit. This is a double unit. Whenever I can, I want to start with my single unit. Now that I've got liters on top, guess what? I can put liters on the bottom, and that's 0.440 moles on top. And again, hopefully we're able to recognize moles per liter. That's what big M is. This is my 0.440 big M, moles per liter. And then next, I need to go moles on bottom, grams on top. For this, I'll need a periodic table, and I'll need to crunch the numbers of the molar mass of magnesium fluoride. So good thing we have one of those pretty readily available. I'll need one magnesium. So there's magnesium, the mass there, 24.3050 grams per mole. I need to add that to 2 fluorines. I've got 2 fluorines here. So the mass there is 18.9984.032, again, grams per mole. The calculator do the heavy lifting here, 24.3050 plus 2 times 18.9984.032. Close those parentheses up. And I'm getting a molar mass of 62.3018064 grams per mole. And there's an addition problem, so it doesn't matter how many significant digits we have, it matters where they're at. This one goes 4 past the decimal. This one goes a lot more than 4. So let's stick to 4. I'm going to underline these last 3. They're not significant. I'll bring that molar mass up here. That's grams per mole. So 62.301806 grams per mole. And I carry at least 2 digits. That's my general rule. I know I've got 3 there, but I only need to carry 2 of them. Hopefully that 4 doesn't come into play anywhere. So at least 2 digits. There's my carried digits. There we go. Underlined, they're not significant. And hey, look at that. Liters is gone. Moles is gone. We have ourselves a mass of magnesium fluoride, which is exactly what we were looking for. Let's crunch. 2.00 times 0.440 times 62.301806. 3 significant digits, 3 significant digits, a whole heck of a lot more than 3. I'm going to want 3 significant digits in my final answer. If you have 2 liters of a 0.440 molar magnesium fluoride solution, you've probably got about 54.8 grams. Oops, not grams per mole. Giving you the wrong unit there. You've probably got about 54.8 grams in that 2 liters. Hey, we've got number 6 left to do. Here we go. How much 0.050 molar HCl solution can be made if we're to dilute 250 milliliters of a 10 molar HCl solution. So we want to know what total volume we can get. How much, that's a total volume, how much solution can we make if I start with 250 milliliters of a very concentrated solution? That's a very high concentration, 10 molar HCl. Yikes. Talking about melting some stuff there. All right, so we are looking for a volume. This time, though, a volume of a dilution. How much of our dilution can we make? And we've got 2 units. I'm sorry, 3 numbers. I suggest you start with one that only has 1 unit. This one has 2 units. This one has 2 units. Let's start with that guy right there. A little different than what we've been doing, though. This one is a volume of the stock. So we have 250 milliliters of stock solution. And experience just letting me know that I want to go from milliliters to liters first. We're working with moles. I know that's going to be in liters. Now I can say in 1 liter of stock, I have 10 moles HCl. And that's my stock concentration. Now we can go from moles to liters of dilution. That's what that moles allows us to do. We're now converting from moles of stock to moles of dilution. And the value there is 0.50 moles per liter. Final step. I guess there's nothing that says we had to have our answer in milliliters. We could have left it in liters, but I usually, just out of habit, usually go to milliliters. There we go. Milliliters of stock is canceled out. Liters of stock is canceled out. Moles of HCl is canceled out. Liters of dilution is canceled out. The only unit we have left, milliliters of dilution. Let's crunch. 250 divided by 1,000 times 10 divided by 0.050 times 1,000. And I had a big old number of 50,000 milliliters of HCl is what we could make. Got to check our significant digits here. This number has 2. There's no decimal, so that 0 is not significant, just the 2 and the 5. 3, and just 2 here also. Again, zeros to the left never count, decimal or otherwise. So I need to write this with just 2 significant digits. That can be a little bit challenging. Luckily, we know how to write in scientific notation. And if you don't know how to write in scientific notation, you can pretty easily get there on your calculator by hitting second, psi. Go over to your psi option. So second, DRG. Went over to psi option, hit enter, and there we go. 5 times 10 to the 4th. There's our 2 significant digits. We still have the 50,000. That's what that 10 to the 4th tells us. And that's our milliliters HCl. Of course, that's a dilution. But we could make 50 liters of our dilution. That is some strong stuff right there. So there's our answer. Hey, for those of you guys interested, there is a bonus problem, but I'm not going to help you with that. It's bonus for a reason. Give it a shot. Those of you who are interested. But otherwise, guys, have a great weekend. I'll see you next week. Mr. Richardson, signing off.